Friday, everybody. You know it's a good Friday because it's Excel Friday. And you know Excel Friday is good because it's all caps, bold, and three exclamation marks. Okay. So I take this stuff pretty seriously. So yeah, we're going to be doing some more Excel stuff today. And there's a little bit of a wrinkle to it as what we're going to be doing is not going to exactly align with the book. I'll explain why. So let's just go ahead and first of all, hopefully you've got your sample data sets open. I want to take a look at something, not at the data set itself, but actually Excel. Let's go ahead and go to File and down to Options. File and Options. Once you click on Options, it's going to give you this menu here. I want to go to Add-ins. And some of you may have the analysis toolpack enabled. If you don't, do not enable it. I'm actually going to disable it. We're having some issues currently on the network with analysis toolpack. If I'm correct, basically what's going to happen is that it's going to say that there's an error, not so many words. If I click on data, yeah, it gives us a bit of the Visual Basic error. Now, what does this mean? It basically means that some of the analysis toolpack stuff that we're working on right now is not available, which is problematic because that's actually what we're going to do today. We're going to do a histogram. Now, histogram is nothing exciting. It's just basically a way of summarizing data. But I was trying to figure out a best way to work around that. So we're going to work without the analysis toolpack option. So I'm actually removing my analysis toolpack so I don't get that annoying pop-up anymore. So if you got analysis toolpack enabled, it's not a big deal. You will get a little bit of an error when you click on data, but if you remove the analysis toolpack, voila, it's gone. Okay, you've learned something today. Have a great day, great weekend. Now, unfortunately, we're not going to stop there. We got too much to talk about, too much exciting things to do. So let's go ahead and talk about our analyses today. We've done descriptive and diagnostic analysis, which are basically talking about what happened and why did it happen. We still got two more analyses to talk about from chapter 10. So we've got predictive and prescriptive. So let's just talk about some ways that we can approach this. Now, the first of these is going to be something called a calculation of bankruptcy risk using a predictor called Altman's Z-score. Altman is a financial researcher. I believe he's still alive. I think this is a fairly recent discussion. I could be wrong. But it's using variables that are disclosed in common corporate metrics to actually determine whether or not a company will go bankrupt. And it's the prediction of the model power of it is very, very high. It's considering all the variety and all the chaos that gets created in corporate America nowadays. Having to add this simple model that can actually predict whether or not bankruptcy occurs is pretty impressive. As you can probably guess, this is a very good illustration of something what we want to call predictive analysis. If we can look at numbers and predict if a company is going to go bankrupt, that is a powerful investing tool, a powerful decision tool for our stakeholders. And so this is something we're going to utilize today in a very large data set. I believe this is like 2,300 records. Scroll all the way down to the bottom, maybe more. Yeah, 2,300 something records. Basically, this is a data dump from a CompuStat. CompuStat's a database that actually holds information for corporate disclosures on an annual basis. And so we got some information here that's not normally accessible to the church state through our use of the textbook. So what we're going to do is we're going to use this information to, first of all, calculate Altman's Z-score and then categorize according to risk. We are going to have to take a little bit of a different approach because we don't have the histogram available to us, but that will allow us to explore something that we haven't explored yet in our analysis of Excel. So here's what we're going to do. I want you to scroll over to the right side of the data, and we're going to set some column parameters real quick. I want you to type in X1, then next to it X2. You can kind of see where I'm going. We're going to go through 5 of these, X3, X4, X5. And by the way, most of this is still going to be contained in the book. If you get lost and are trying to keep up with me, you can actually refer back to the information in the book. We're just going to be following these formulas that are listed in the book. And I guess that's on page 275. Yes, 275 in the textbook. So, and then we're just going to add a couple more column titles. So I'm going to say Altman Z. I'm actually going to add another one in column S, which is not in the book. This is going to be for the purposes of our analysis today, since we're not using a histogram. I'm just going to type in the letters DR. That stands for decision rule. And we'll talk about what that means here in just a minute. So first of all, let's go ahead and do the simple stuff of calculating Altman's Z-score. So basically what we're going to do is we're going to calculate based on the parameters that are listed. So if you look, These are the characteristics of Altman Z-score. He basically said, working capital, retained earnings, earnings before income and taxes, market value of stockholders' equity, and sales are all characteristics of bankruptcy prediction. Now, those by themselves are not enough. You will notice these are scaled by certain variables. But most of these are going to be scaled by total assets. Though market value of stockholders' equity is actually scaled by book value of total debts. Okay, so we're going to go ahead and put those calculations in. So let's just go ahead and look at the numbers that are listed here. We're going to put these exact formulas in. So under X1 in column M2, we're going to put in parentheses D2 minus G2 and divide by E2. Make sure you had the equal sign. The last time that I worked this. G2 minus G2 divided by E2. And we're going to be dividing by E2 for most of these. Now you will notice it says in dollars. That's because the origin fields are actually in dollars. This is not a currency calculation. This is actually a ratio calculation. We will make that adjustment. If we make the adjustment now, it will not carry over to other fields because we're still going to put some formulas in, but we'll convert these all to ratio formulas here in just a second. All right. Oops. Let's go back to here. The next one is just going to be a simple, under X2, we're going to do J2 divided by E2. Under X3, we're going to do F2 divided by E2. And again, if you're curious about what these formulas are calculating, you can go back up, just scroll up a little bit, and it tells you each of the variables that are going into the bankruptcy prediction model. So in that first one, working capital, remember working capital back from your finance classes or for 221 is just current assets minus current liabilities. So that was what our calculation is. Okay, current assets minus current liabilities scaled because they're divided by total assets. Then we did retained earnings just a second ago, and earnings before interest and taxes. I guess I can leave this up here so we can still see this down here. So X4, this is our market value stockholders' equity divided by book total of debt. So that's going to be L2 divided by H2. And then finally in X5, we're going to do, sales divided by total assets. So K2 divided by E2. Before we go on, let's just go ahead and make a couple of cleanups, okay? Like I said, these are ratios, so we don't want them to be currency. So let's just highlight columns N through Q, right click, and we're going to change them over to general. Should be sufficient for our purposes. And then, of course, we've got our formulas in, so let's just go ahead and flash fill those down. All right. So we have the inputs that we need for Altman Z-score, but it's important to note Altman Z-score by itself is not just each of these numbers added together. We have to assign different weights to each of these numbers because some of these items are going to be more relevant than others. So the formula that we're going to enter, again, is in the textbook. We can kind of see here. We go down, going to be 1.2 for our first variable, a weight of 1.4 for our second variable, a weight of 3.3 for our third variable, a weight of 0.6 for our fourth variable, and then no weight at all for our final variable. And you can kind of see it's put in here. I will tell you, because of the way Excel works, the PEMDAS formulas, you don't actually need to put parentheses up here as long as you're consistent with your applications of plus signs. So let's just go ahead and put those in there. I'm not going to use PEMDAS because I'm a rebel, okay? I'm actually joking. I'm not a data analyst rebel. My students will tell you that. So 1.2 times M2 plus, I believe it's 1.4 times N2 plus, I'm going to need a refresher. I think it's 3.3. 3.3 times O2 plus 0.6 times P2 plus, and then we're just going to do Q2 because it's a weight of 1, and 1 times anything is that same value. Make sure I got that right. I'm going to be really impressed if I did. My memory is not what it was. 1.2, 1.4, 3.0. Wow. Okay. Kudos to me. All right. Silent round of applause. There we go. All right. So once you enter that formula, go and click enter. You should get a 2.51257. If you don't get that number, then you probably had an error in your formula somewhere. So just check that. Again, compare it to what's in the book. And like we did before, we're gonna flash fill that down. So now we've calculated Altman Z-scores. And if we had our histogram tool available, we could put these nice into compartments, but we don't. So we're gonna have to do a little bit of a trick around this. So first of all, let's go ahead and talk or discuss what Altman Z predictor gives us. It basically says if your Z-score is less than 1.8, that the company is going to be classified as bankrupt or significantly in the distress zone. If they're between 1.8 and 3, then they're going to be in the risk zone or the gray zone. So they've got risk, but they're not probably there's a question about whether they'll go bankrupt. Anything above 3 is going to be in the safe zone, non-bankrupt. So we're going to set those criteria up using our decision rule column, and then we're going to categorize them. All right. So let's go ahead. First thing we're going to do is we're just going to go back to the beginning of our table. We're going to highlight everything we've got, and we're going to sort. What I'd like for you to do is I'd like you to sort your Altman Z column from smallest to largest. Now, there's multiple ways to go about this. This is just the way that I chose to go for today. Again, we could probably use something, we could probably use a pivot table. We could use some other metric, some other format for this, but I thought this is something interesting. So now we've got it sorted according to Altman Z-score. And you'll notice some of these have negative Altman Z-scores, which is probably not good, okay? Probably not very good. So for the first category, we said that these are the ones that are in distress. So under decision rule column, everybody gets like some people talking, it's like, we got the sorting worked out?
Sorting one more time.
Sure. Okay, so we're going to highlight the entire table. We're going to click on sort. We're going to select sort by Altman Z because our data has headers. Okay. We're going to do cell values from smallest to largest. And once you click on that, it'll sort the entire table according to that score. Should have a negative 18.5 with that. That company is they probably don't exist anymore. Okay. Here's what we're going to do. I want you to type in, assuming that you've got this sorted correctly, I want you to type in distress in S2. Then we're going to copy that. And we'll hold down the shift key and I'm going to hit just page down. And I'm going to go until I reach 1.8 or just right before we reach 1.8. So again, I'm holding down the shift key and hitting page down. This is a simple way to show that we don't miss anything. We get to row 306. That's going to be the end of our stress zone. So go ahead and hit Control V. And all those are classified as distress. So you should have rows 2 through 306 classified as distress. Starting at 307, let's type in risk. Because this is our middle area, it's our gray zone. Do the same thing, we're going to copy it. And we're just going to hit Shift and page down until we hit 3. Because remember, 3 is where we hit our safe zone. So we can go a little bit faster because there's more records here. A little bit too fast. So we're going to get to row 822. Paste in risk there. And then 823, we should type in safe. And then we're just going to flash fill that because everything else is safe. So just for context, we should have distress through like row 306, I believe is where we said it was. Maybe 303, I can't remember exactly which one. Yeah, 306. We have risk through column 800, no, sorry, not column, row 800, thing or other. 822, and then everything else should be labeled as safe. Now that's fine, okay? Well, let's see if we can summarize this to get some a little bit more acquainted counts, okay? Here's what I'd like for you to do. Let's go ahead and highlight the entire table once more. And we're just going to create a simple subtotal. This actually looks different on my computer than it does here. All right, so apparently subtotal is not in Excel where I thought it was. It's under data normally, but I just typed in subtotal in search, clicked it in there. All right, so let's go ahead. Here's what we're gonna do. We're gonna go where it says at each change in, I want you to type in or enter DR for a decision rule. So basically every time decision rule changes, it's gonna create a new subtotal. And then for the function where it says count, it doesn't have anything currently selected. So let's select, or actually has DR selected. Let's select ultimate Z-score instead. That will add our count there. All we are doing here is we're just going to group these according to whatever their category of risk is, so we can get a count of the number of records in there, which is going to be our representation of a histogram. So at each change in DR decision rule, we're going to use the function count for ultimate Z-score. It's going to tell us the number of records. And you will notice that some pop-up boxes occurred on the left. Click on number 2. Now we have a address count of 305 records, a risk count of 516 records, and a save count of 1,508 for a grand total of 2,329. And if we wanted to look at each of those individual areas, we could click on the plus sign next to them. Yes. So to highlight all.
Yeah, like that. Highlight.
Yeah. So go to the original cell, A1, hold down Control Shift, right arrow, down arrow.
No, okay. Is that what you click in the toolbar at the top?
Oh, I typed in subtotal up here.
Okay.
Yeah, because I couldn't find subtotal in the because again, subtotal is up here, and I'm sure it's somewhere up here. It's just I'm old and I'm not used to change. So, but we typed in subtotals here, allowed us to put in our subtotals. All right. So an interesting workaround, to say the least. But it does give us the information that we have for a histogram. Yes.
It's under the outline.
Their outline. Okay, there we go. All right, good to know. All right. I knew it was there. I just, yeah, again, the problem. You all will eventually reach the age where you're muddled and confused, and I hope the best for everyone. Hope the best for everybody with that voice. Okay. So yeah, when you deal with unexpected situations, you have to adjust. I've been dealing with a lot of unexpected situations today. All right, none of that. Let's just go ahead and move on to our next one. So let's go to part 2. So we've got all 3 of our analysis, previous analysis. We still have this prescriptive analysis. So we're going to do something that is a little bit of throwback to 221. So remember when you used to talk about break-even analysis back in 221? It's like trying to determine how do we have to perform in order to actually make sure that all of our costs are covered by our revenues. So our expenses and revenues exactly match, so profit is 0, right? So you can calculate break-even a number of ways. You can calculate it break-even ratio. You can calculate break-even in dollars. What was the very first thing that you had to calculate break-even in? Then units, break-even in units, yes. So we're going to do some analysis like that. And the nice thing is that Excel actually has some tools that we can do for us. We can also do target profit analysis, which if you remember, if you had a good instructor for 221, like if you had like me, nobody in this class had me for 221. I stopped teaching 221 a few years ago, but if you had 221, it's like target profit and break even are exactly the same formula, except you just put 0 in for target profit in the break even formula. So that was one of the keys that I taught my students back then. I'm sure Dr. Deers, Dr. Shoniwell, or Dr. Otero, whoever you had probably did the same thing. They're all excellent instructors. So let's go ahead and set up our formulas here. So I'm going to do something really quick. There's a few adjustments that I want to make. So first of all, I want to do this for column 2, but we're going to do it for all the columns except for probably unit of sales. So let's just go ahead and highlight, or not column 2, row 2. I don't know why I'm transposing this today. Let's just right click on the price and format cells. And we're just going to change this to currency to 2 decimal places, because these are values. And we're going to do the same thing for rows 4 through 9. Okay, you can just use the format painter or just, yeah, or whatever you want to do, but either way. So we have that set up. All right. Now this asks us to do some things that we already know how to do, but may not have thought about. So saying variable cost, all right? So we have our unit cost, we have our units of sales. Can we calculate total variable cost from that? Yep, pretty easily. Variable cost is just basically our unit cost times the number of units. What about total cost? Total cost is just Variable cost plus fixed cost. Let's go ahead and do that. Variable cost plus fixed cost. What about sales revenue? Sales revenue is just basically going to be the units of sales times their price. So say price times unit sales, just stay consistent format. And then net income. That's just revenue minus cost, right? So revenue minus cost. Nothing too confusing there. Again, just a reiteration of how you set up numbers in the income statement. Takes a second, but it's easy to pick up. This is not good. They've got a net income of negative $250. That is not something any organization wants. And if you go ahead and let's go ahead and highlight those four cells that we've now input, we can actually, let's see, we can actually copy those over. I tried to flash fill, but I don't think that'll work. And they're consistently running negative numbers, which is not a good position. I will say if you're a business that's consistently operating negative, you're generally not going to stay in business. I don't know how Tesla does it. Okay, that's just one of those weird things. Anyway, let's go ahead and what I'd like for you to do is we're going to highlight cells A3 through M3. And I want you to just add a yellow highlight here. And this will compare why we're doing that here in just a second. So we'd like to figure out what it is that we want to do for break even. We want to be able to set our unit sales to calculate or to where net income is 0. Now, mathematically, this is a pretty simple formula for calculating this back when we learned at 221. But we can do better than that because we have automated tools that allow us to do that. So here's what we're going to do is that we're going to go. Oh, now it's, oh, I should change it over here. Okay, yeah. So we're going to go to data and we're going to perform what's called a what if analysis. So I want you to click on that and let's go for goal seek. Now, a quick note, goal seek cannot be copy pasted. So if we want to do this for every single one of our cells, we have to do this individually for each of the observations. We're not going to do it for every single one unless you just feel like being an overachiever and seeing how it works out for each one. We're going to do it a couple times to see the analysis. So what we want to do is we want to set cell B9. And if you highlighted that already, great. If not, go ahead and just click on B9. And we want to set it to value of 0 because we want that number to be 0. We want to break even. Profit or our net income, our profit to be $0. How are we going to do that? We're going to change this cell right here. We're going to change B3, which is our units. Okay, those are our units. That's why I highlighted that because that's going to be our manipulating variable. So if we do that, click OK. It does the automatic analysis for us. So you notice this number changed from 300 to 400, and now our net income is now 0. So in order to break even, they've got to sell 400 units. And we could do that for every single one of our net income items. But let's do something a little bit different just for fun, okay? Just because we're all together and we're enjoying our Excel time together. So click on C9. Let's do the same what if analysis. So senior manager, January, you found that out. You're like, January break even is good, but I want to earn a profit in February. So we're going to set cell C9 to 1,000. We're going to change cell C3 to do that. So it does the calculation for us. It says if we want to make $1,000 in February, we need to sell 625 units. And we can manipulate those variables as necessary to actually achieve whatever our goals are. Which is pretty easy. It makes the process of break even a lot less about mathematical formulas, more about looking at the values and copying that over. Makes it a very easy endeavor for us. But you can see here, this is a prescriptive analysis. This is what we believe will happen. What do we have to do in order to change the results or to achieve the results that we want? So this is a very powerful tool to our disposal. All right. With that, we are done with our different types of analysis in Excel. We'll be back to more of our traditional Excel stuff next week. But we still have homework to talk about, so let's go ahead and do that. All right. Question number 1, which of the following best describes a data visualization? All right, so this is just a definition, kind of what you would see representative of on an exam. So the part of the information value chain, it could be, but that's not how we define a visualization. The tool for preparing the data, we could use data visualization tools to prepare the data, but that's not the ultimate objective. That's not the data visualization itself. It's a tool for recording data transactions. That would be more of along general ledger tool or ERP tool like we're using for NetSuite. So we got D, a graphical representation that presents information to decision makers. I like that definition, and that is in fact our answer. Again, do not default to E. Even if E is the correct answer, if it's none of the above or the all of the above, make sure you look at all the answers, because it's not always going to be all of the above or none of the above. It definitely will not always be all of the above on the exam, but we're learning that. We're learning that. Okay, question number 2. Which of the following is not a basic activity for data visualization? So let's go ahead and look at B, C, and D for no apparent reason. Understanding the data, is that something we need to do? Yeah, that's something we talked about on Monday. We said, we're looking at the table and model view, and what is it we're trying to do? We're trying to understand what the data is telling us and prepare the data for our analysis and for our visualization. Selecting the data visualization tool, that's our Power BI, that's going to be in our report view, and the developing the visualization is how we ultimately create the visualization. So these are all things that we did as part of our visualization analysis. Documenting the business processes that generate data. No, that would be something that occurs earlier, okay? It's something that occurs in the business process analysis phase. We would not necessarily do that as part of visualization. It's something probably we should know to do a visualization and do an effective visualization, but it's not part of that. So A is our answer. Question number 3. Which of the following is an important consideration in designing a data visualization? All right, so let's just go through the answers. Choosing the right chart. Yeah, we talked about the necessity for that. Depending on what type of analysis we're doing or what type of analysis we performed or what we want to represent, we're going to use different charts. Okay, if we're doing a categorical analysis, then we probably use a bar chart, or we can even use a proportional share chart like a pie chart or a donut. If we're looking at univariate analysis, we're going to be using those histograms. We're going to be doing a multivariate analysis. That's when we would use the scatter plots. So the different tools that we're going to use are going to be representative of the different type of visualization. Do we want to use explanatory titles? Yes, it's good to document everything. And by I mean everything, I mean everything, okay, from here to the end of time. Do we use color or size to draw attention to key insights? It's a good idea, okay? Has somebody done that recently? I don't know. Okay, somebody used definitely size to draw insights along with exclamation marks and bolds, okay? So there's I don't necessarily use colors anymore because, that's kind of a subjective one, but there's certainly opportunities there. Do we need to define chart elements clearly? Yes, if people don't know what the chart is saying, then it's really hard to interpret what the chart chart means. So all of the above is a pretty easy answer here. Pretty easy. Yeah. Again, not going to be as easy, simple on the exam, but again, it's important to think through every single one of these items. Which of the following charts is used to show trend over time? I've already told you questions like this are 100% going to be on the exam, so you need to be prepared to answer these questions. The trend over time, again, that was our line chart, okay? That was the line to show the trend that looks the way it looks. Again, don't conflate this with a bar chart. Even though you can actually use those interchangeably within the visualizations, a line chart should be used almost exclusively for trends over time. All right. Which of the following is not part of the common steps in using a data analysis tool? Well, let's just work through these. Get data. Wouldn't that be great if we didn't have to actually have data for data analysis? That would make life so much easier. I just basically sit on Excel and I just say, tell me what this is. That just gives me the visualization. Maybe AI will eventually reach that point. Who knows? Okay. Unfortunately, right now, because we still have to do visualizations ourselves, we do have to get data. Do we need to set the relationships among tables? Well, yes, even though Power BI does that for us and does a really good job, we still have to make sure the relationships are correct. So we have to make sure that's set up for a visualization. Select the attributes for the visualization. Yeah, because remember, we look at the tables themselves and see what are the attributes within the tables and say which one of these attributes we're going to use for a visualization. In our example from Monday, we pulled in the states and we pulled in the flower types and we pulled in amounts, the amounts sold. So the total amounts. So those are going to be examples of what we'd be looking at in there. What about deliver the visualization to the decision maker? That's something that's a common step in the data analysis or steps in using a data analysis tool. Seems like it'd be after the fact. That would be something we do after the visualization is done. It's definitely good to have that visualization to be able to deliver to somebody, but it's not part of that using tool. So D is our answer. Which of the following is not characteristic? Sorry, did I do this one? I did not do this one. I did this one. Which of the following is true about Excel tables? Are they created from rectangular data ranges? Have you ever looked at an Excel table? It looks like a big rectangle. Okay. Yeah. So yeah, it does extend out. Actually, I think it extends more horizontal or vertically than it is horizontally, but it is more of a rectangle. Yeah. User can add a totals row. Has anybody ever tried to use it to do a totals row in Excel? It is a thing you can do. Yeah, that is a thing you can do. Headers include filter buttons. We did auto filter. That was one of the things that we had. It was a neat tool to have. Table is automatically formatted. Yeah, it is formatted. There's a default format, but that's probably a little bit misleading. But I would say it's still automatically formatted because of the default. So all of these are true. Which of the following characteristic of a pivot table? I want to bring Dr. Caden as a guest speaker, but she's a little bit busy here, so she can tell us all this. Which of the following characteristics of those pivot tables? Summarize the data and arrange an external data source, yes. Multi-dimensional summaries, yes. Format the numbers in the value field, yes. User can choose subtotals and grand totals. All of these are characteristics of the pivot table, so yes. Which of the following is not true about a pivot table? All right, so can users select report row variables? Is that something we can do in a pivot table? Yes, in fact, it is something we've done in a pivot table. So we can also select report column variables. Can we include grand totals in a pivot table? That's what makes it nice. We can actually look at analysis in a number of different ways, including grand totals. Must we sum values in a pivot table? Is that a requirement? No, we can do counts. In fact, we have done counts before. So we have different types of analysis. So D is likely our answer, but users can format values in the pivot table. Kind of be a useless tool if we could not format it. So A, B, C, and E are all correct. D is something that's not true. So that's our answer. Right, moving down to question number 15. Which of these is not a view in Power BI? So you may say all of the above are they're not views in Power BI, but keep in mind that we do know that the relationships view is a valid one, as we talked about that. That's where our report view is a valid one because that's where we actually do our analysis. So we create the visualizations. We talked about data and relationships view, but we didn't use those terms. Remember I said that in Power BI, that when you look at the Power BI, that we've got the table view and the model view. But in older versions of Power BI, table was called data and relationships, or models was called relationships. Why is this different in the textbook than it is in our version of Power BI? What was the reason that I gave for that?
BI updates a lot.
Yeah, updates a lot, and they even update terminology to make it a little bit clearer. So Power BI updates every single month. This book is like 2-3 years old, so it's referring to old formats for Power BI. Does that mean it's any less relevant? No, it was still using the same tables, the same items. They just use different terms. So that's something to keep in mind. So that's something I warned you about on the homework, is that you do need to know those terminologies. I will use the correct terminology on the exam, but it is good to know that this may change in the future for you as well. And something that might be called model today or called relationships today may be called something else in the future. I guess model and table today, yeah. All right. That's it for our multiple choice. Let's go ahead and move on to our discussion, questions, and problems. All right. So this is an interesting philosophical question. And I don't know if philosophy can be applied to visualization and analytics. But if data analytics capabilities are offered by Excel, why would we choose Tableau or Power BI? And I think hopefully by this point, everybody should have a pretty good answer for this. So Excel is a good starting point for our analysis, but the amount of visualization we can perform in Excel is extremely limited relative to other tools. Tableau and Power BI are far more advanced in their capabilities. They do provide real-time filtering, whereas Excel does not. So that's something that's really important, at least not in most of Excel's tools, they don't. Does that mean Excel is irrelevant? No, absolutely. Excel is a good general tool for a lot of different types of tasks and data analysis. Visualization, data analytics, cleaning, all of these can be done in Excel and very effectively. That's one of the reasons we're spending so much time talking about Excel, is that these are transferable skills into other platforms. There was another reason that you may have mentioned that I do want to talk about when I reiterate. So remember we were talking about Excel, and when you manipulate data in Excel, what happens to the source data? The source data changes, okay? In Excel, the source data changes. That's why when you're doing a data analysis in Excel, you should have your original file. You should store that somewhere safe and secure, and then copy it and do your analysis in a new copy, because you don't want to change your source data. Is that a problem in data visualization tools like Tableau or Power BI? No, you import the original data into a new format, and then you manipulate that, but it retains the integrity of the original data. So something like Power BI, Tableau, other tools as well, IDEA and Alteryx, all of these have the same characteristic, and they take the original data, they allow you to dissect it and analyze it, but do not change the source of the original data. You can change the format, but the original data stays the same. You can visualize, but the original data stays the same. You can remodel. All of these things are things that we can do within these tools that do not affect the integrity of the original data, which is really an important point to make. So two kind of high-level points to consider. First of all, Excel or Tableau and Power BI are more powerful than Excel, at least with respect to visualization, and they help us retain the integrity of data, whereas Excel would not. All right, last thing. Power BI, I'm not going to spend a lot of time on this because I'm assuming everybody kind of put together what was dictated. So hopefully your deliverable looks something like this. So this is kind of interesting in the fact that we've actually got 3 visualizations at the same time. And what I really like about this is not that you can put the visualizations up, but you can kind of see the effects of what happens when you add filters. So if you've got your homework up, if you don't, it's not a big deal. Not something that's required. But let's just go ahead and add filter on all pages. We'd only have one page, but just for content, just to see how it works, put product description up there. And what's neat about this is that we've got 3 visualizations on the same page, but we can add filters that actually affect all 3 visualizations simultaneously. Which I never get tired of seeing that. That's actually kind of neat. Some of these do not have data, by the way, so I'm just clicking on these arbitrarily just to kind of see how they change. You know, one thing to keep in mind is that we didn't have to do any manipulation of the tables, but the table views are listed here along with everything that's put into there. And we did not actually have to change the relationship, but this was a pretty complex relationship view. We had to identify that our sales table was our primary table, and all 3 or the 3 other 3 tables linked through the single table. So this would again be something you want to check. Basically, what this means is that our 3 primary keys from stores, our primary keys from stores, channel, and products would all have to be in the sales table and all have to be correct in order for the integrity to match. But you can see the directions. The primary keys are coming from these external tables into the sales table, and all 3 of them are listed as foreign key in this particular table, which is why we have those relationships that exist. Which is pretty impressive if you think about it, because we actually have one table that's integrating all 3 of the other tables, but we can actually perform analysis between these tables now. There's no actual relationship between these tables, but because they integrate with the sales table, then we can perform analysis on all of them simultaneously. So that's really cool. Something that Power BI kind of did for us, which is really good. All right, that does it for today. So we'll be back on Monday for chapter 12, I believe. So see you all then.